Hi friends, myself Arvind from Department of Electronics and Communication Engineering, Rajiv Institute of Technology, Hassan. In this lecture, I am going to make an explanation of circular convolution in frequency domain and its implementation using the Scilab. So we are going to have a view on the frequency domain approach for circular convolution. Let us first go through the various steps involved in that. So first step, calculate the output sequence length capital letter N. Apply endpoint DFT to the first input sequence, that is x of n, so that we can get x of k. Then apply endpoint DFT to h of n, the second sequence, so that we can get h of k. Then multiply the sequence x of k and h of k to get y of k. So this is for the realization. Then apply endpoint inverse DFT to y of k so that we can get y of n. And this y of n is the circularly convolved sequence of x of n and h of n. Let us go through a simple example of circular convolution in frequency domain. The two sequences x of n and h of n are given by x of n is equal to 2, 1, 2, 1, h of n is equal to 1, 2, 3, 4. Find output sequence y of n which is equal to circular convolution of two sequences. Now getting into the solution, we are just noting down the first given sequences and the length of each of these two sequences. Now as per the step, calculate the output sequence n, that is given by n is equal to maximum of the given input sequences. So in this case, both the sequences are having the length 4, therefore the output is also 4. That means the capital letter N will have the length 4. The second step, apply endpoint DFT to x of n to obtain x of k. So this is what the formula, and the length is 4. We are following the matrix method over here. So twiddle factor representation, the input sequence, by multiplying that we are going to get the x of k 6020. Next step, apply endpoint DFT to h of n to obtain h of k. Again 4-point DFT calculation, matrix method. By applying that we are going to get 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Next step, multiply x of k and h of k to obtain y of k. So the two sequences are being multiplied. This is a dot product basically. That means the location wise we are going to make the multiplication. By that we are going to have the result y of k is equal to 60, 0, minus 4 and 0. The last step, apply endpoint IDFT to y of k to obtain y of n. So we are applying the inverse transform over here to y of k, and finally we are obtaining the result y of n is equal to 14, 16, 14, 16. And remember, in all the sequences we are going to have first element itself as the origin, including the input as well as the output. Let us get into the Scilab code of it. So circular convolution using DFT and IDFT pair. So we are going to define the length of the sequences. So length L is equal to 4, N is equal to 4 we are going to define, and this N is going to get the number of points of DFT that we have to consider. Anyhow, we can also calculate that by using the formula within the code, but anyhow it is defined over here for the sake of simplicity. And then x is equal to 1 to 1 the first sequence, then h is equal to 1 2 3 4 the second sequence. Then as per the procedure, now we are going to follow the step by step. In the first step we are going to calculate the DFT of the first sequence x. So we are applying the FFT for that. So FFT of x comma minus 1. So this minus 1 indicates this is the forward transform we are calculating, and whatever the value calculated that will be displayed using the command DISP. In the next step, the DFT of the sequence H is being calculated. So that is being calculated over here, and the same will be displayed on the console window. In the next step, the two sequences x and h are multiplied to obtain y. So that is being done over here. And the same values are being displayed using the disp command. In the next step, the inverse transform for capital letter Y is obtained in order to obtain the circularly convolved sequence. So here the same FFT function is used, but it is +1. This +1 indicates this is the inverse transform we are applying. And then the circularly convolved sequence is being displayed on console window. Then the next remaining part of the program is just to display the graph of the input sequences as well as the output sequence. So subplot is being used, then the discrete plot representation is being done over here, and this is what 0 to n minus 1, the x-axis representation, and the input is what the x, and then the second one 0 to n minus 1, the x-axis representation, and the input value h is being displayed. Then similarly, finally the output sequence y is being displayed in the similar manner. And within this plot, the -1 as well as the -1 represented here, we are going to represent the way we need to indicate the final set. That means with a symbol plus or something else, or with a different color. So that is what the indication. But this -1 in the plot 2D3 and 3 over here does not have any significance other than the way we are going to represent. We can just stop to y itself, then also we are going to get the correct graph representation. Now let us make an execution of this code. First let us go through the values. The input is not being displayed over here, it's available here itself, and then the DFT of the sequence x is being displayed first here, 6020, and DFT of the sequence h, that is being displayed over here, and then multiplication of this x and the h is what the y we are going to get, capital letter Y, that is being displayed here. And after applying the inverse transform for this capital letter Y, we are going to get the small letter y, which is the circularly convolved sequence of x and h, and that is what 14, 16, 14, 16 we are going to get. Now let us go through the graph of the same. Now this is what the graph we are going to have. So graph is being taken only with respect to the input two sequences as well as for the output. So let me say, as you can observe, the input sequence, the first sequence we are going to have, that you can observe over here. So 2 1 2 1 is the first sequence. So this is what the 2 which we cannot observe, and here is the 1 at the lower limit itself, so that point is available over here. And then 2 1 we are going to have. The next one is we are going to have the sequence as 1 2 3 4, so that you can observe here. So 1 is present at here itself, and then this is 2, this is 3, and this is what the 4 we are having. And whatever the plus symbol you are observing here, in order to obtain that, we try to work out with that -1 in the plot 2D3 command. And then the final output is this one. So in the final output, we are going to have 14, 16, 14, 16 the result. So 14 is here itself, this point that we cannot observe on this graph. Then 16 as we can observe, and then 14 again it is on this line itself, and then again 16 we are going to have. Thanks for watching.